Hello everyone. So we are starting unit 13, which is probability. We have one more unit until we are finished with the Algebra 2 curriculum. So, probability. What we're going to look at today is just an introduction to it, so the very basics. So, as the do now, we have some definitions. These definitions are going to be used, these words, are going to be used throughout the unit, so you just have to be familiar with what they are. So, an experiment is a process that occurs that have well-defined outcomes. That means that they have an outcome. And an outcome is a result from a single trial of the experiment. So, these two pretty much go together. An event is the collection of one or more outcomes, and a sample space is a collection of all the outcomes of an experiment. What is probability? You've definitely looked at probability and you've probably used it in your life. Probability is around you all the time. So the probability is the why did I just do that? Is the likelihood of an event happening. Here's the basic math definition. Now this one up here, it can look very confusing, okay? It says that the probability is equal to the number of outcomes that fall into an event E and the number of outcomes that fall into a sample space. This could be a little confusing, so I like this definition, the one in the simplest way possible. So the probability of an event happening is the number of ways it can happen over the total number of outcomes. For example, flipping a coin. If we want the probability of flipping heads, okay, that would be the number of ways it can happen. There's only one way you can flip heads, and the total number of outcomes is 2 because you can have heads or tails. So that would be an example of using this definition. Moving on, a probability is a number between 0 and 1. This is super important. Now, when we look at probability, a lot of the times we convert that number to a percent. So 0 means that there's a 0% chance it will occur. 1 means there is 100% chance it will occur. We're just converting the numbers to percents. So if we have 0.5, 0.5 is the same as 50%, 0.65 is the same as 65%, and so on. In case you forgot how to convert, that's okay. There are 2 ways. So to convert this decimal to a percent, we can multiply it by 100. If we do 0.5 times 100, that will give us 50%. Or another way, this is kind of the shortcut. You can take this decimal and move it over 2 spaces to the right, put in a placeholder, and that's the same thing as 50%. So that's how we convert the decimals to percents. All right, let's get to an example. So in this problem, it says an experiment is run where a spinner is spun around a circle with 5 equal sectors that have been marked off as shown. What is the experiment? So here, if you physically have a spinner with an arrow, the experiment would be to spin the spinner. Okay? Give one outcome of the experiment. So if we were to spin this spinner, an outcome, for example, would be to land on 4. It could also be to land on 3 or 1. Any of these numbers is an outcome of the experiment. So I'm going to say here, for the spinner, to land on 4. It could have been any of the numbers though. What is the probability? So now we're finding probability using, I'm going to go back for a second, using this. What is the probability of spinning the spinner and landing on an odd number? What is the event and what outcomes fall into the event? So let's talk about that. The event is landing on an odd number, okay? So the event would be landing on an odd number. The outcomes. So let's look at what numbers could be a possibility here. So we're talking about odd numbers. 1 is an odd number. 3 is an odd number. And 5 is an odd number. 2 and 4 are both even. So our outcomes could be either 1, 3, or 5. These 3 are our odd number options. Now let's find the probability of spinning an odd number. Okay, so remember, it's your favorable outcomes over your total outcomes. Now, our favorable, we want either a 1, a 3, or a 5. There's only 3 numbers there. So 3 is going to go on the top. Our total outcomes, there are 5 spaces on the spinner. So that is going to be a 5 because there are 5 spaces. Now, this isn't the only way you can write this. You can convert this to a decimal and to a percent as well. So I'm opening up my calculator right now to show you how to do that. If this thing ever loads, it always takes forever. Oh, there we go. Some progress. Here we go. Okay, so our fraction was 3 over 5. So I'm going to do 3 divided by 5. When I do this, it changes it to a decimal for me. So this is the same thing as 0.6. Now we can have it as a fraction, we can have it as a decimal, but we can also have it as a percent. To change 0.6 to a percent, multiply by 100 and you get 60. So this is the same thing as 60%. All 3 of these representations are saying the same thing. So whichever one you like to use, you can use. Okay, moving right along. Given the definition of probability between what 2 numbers must all probabilities lie, explain. We did talk about this a little before. All probabilities must lie between 0 and 1 because the 0 represents a 0% chance of something happening and the 1 represents a 100% chance. Now, think about something actually happening. You can't go into a negative percentage, and you can't be above 100%. So that's why it's between the 0 and 1. Okay, some more definitions here. So we have theoretical probability, and we have empirical or experimental probability. Theoretical probability is based on reasoning. You're not actually doing the experiment, but you already kind of know what the outcomes are going to be. For example, flipping a coin. When I did the example before, I'm going to turn back. When I did this here, I didn't actually flip the coin to figure this out. I just used my reasoning skills. Also, for this example here, we didn't actually spin the spinner to find this probability. We just used reasoning skills. So that's what theoretical probability is. Empirical or experimental, that's based on experimental data. So if an experiment was conducted, you have results based on it, that's when you would have empirical or experimental probability. So let's look at our first example of theoretical probability. So it says a fair coin is flipped 3 times and the result is noted each time. A sample space consists of ordered triples, such as HHT, which would represent head on first toss, head on the second toss, and a tail on the third toss. So part A says draw a tree diagram to show all the different outcomes. Now, a tree diagram is a good way to organize your data because you can start listing. Let's say you already start with the first option being 3 heads and then 3 tails. That's fine, but it could be easy to miss one of the outcomes when just listing it. So we're going to do a tree diagram. So the first part of our tree diagram is going to represent our first toss. Okay? So when you toss the coin, you either get a heads or a tails. Okay? Now, the second toss, for the second toss, you have 2 options. You can either get a heads or a tails. Same applies with this. You can either get a heads or a tails. Now, for your third toss, the same will apply. You can either get a heads or a tails. For this one, you can either get a heads or a tails. And the same apply for all of these. Okay? So this is what a tree diagram is. It lists out all the possible outcomes. Now we're going to list them in ordered triples. So what I like to do is I like starting this way and kind of making my way. So the first one is heads, heads, heads. Heads, heads, heads. The second one is heads, heads, tails. So I like going off each branch. Now this branch is completely done. Now we look at this one. We have heads, tails, heads. Then we have heads, tails, tails. Okay, so now this whole branch is done. Let's look at this one. We have tails, heads, heads. Then we have tails, heads, tails. Then we have this branch done, working on the other, tails, tails, heads. Then we have tails, tails, tails. Okay? Now we've listed every possible outcome and it says how many are there? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total outcomes. All right, now it says find each of the following probabilities. So the first one is the probability that we will get all heads. Okay, looking at all of our outcomes here, there's only, I'm actually going to color code this. So I'll do this one in purple. So the probability of all heads, we only have one of these that has all heads. So only one out of our 8 total outcomes will give us all heads. Now remember, you can write this in different ways. You can have 1 over 8, or you can change it to a decimal, which would be 0.125, or you can get it in a percent by multiplying it by 100 and get 12.5%. All 3 of those are perfectly fine answers. Now let's look at part B. It says the probability of exactly 2 heads. So 2 heads. So we want exactly 2 heads. This won't work because there are 3 heads. But this one has 2 heads. This one has 2 heads. This only has 1. This has 2 heads. That only has 1. And that only has 1. So there are 3 possibilities of getting 2 heads out of the 8 total outcomes. Okay? And lastly, we're finding the probability of all heads or all tails. So probability of all H or all T. Looking at what we have, here we have all heads, and here we have all tails. So those are our 2 favorable outcomes out of our 8 total outcomes. Now this fraction you can actually reduce. This reduces to 1 over 4. Okay? So this would be a theoretical probability example. Now an empirical example. Remember, empirical is based on an experiment. So this says, a survey was done by a marketing company to determine which of the 3 sodas was preferred by people in a blind taste test. The results are shown below. So since a survey was done and data was collected, that's what makes it empirical. It says, find the empirical probability that a person selected at random from this group would prefer soda B. Express your answer as a fraction and as a decimal. Okay, so we're looking for the probability that they would prefer soda B. Okay, now here's soda B. 24 people who took this survey preferred soda B. So 24 people out of the total 53 preferred soda B. Now it wants it as a decimal to 2 decimal places. So let's figure out what that is using our calculator. We do 24 divided by, I think it was 53. Yeah. 24 divided by 53. We get this long decimal. It wants it to 2 decimal places, which is right here. This 2 is under a 5, so this will stay a 5. It won't round up. So that is equal to 0.45. Now it says, find the empirical probability that a person selected at random from this group would not prefer soda A. And then it says, again, express as a fraction as the decimal. Now, if they would not prefer soda A, that means they prefer soda B or soda C. Okay? So there are 24 people who prefer soda B and 11 people who prefer soda C. So the probability that they would not want soda A, well, if we add up these 2 numbers, 24 plus 11 will give us 35. So 35 people do not prefer soda A. They prefer soda B or soda C out of the 53 people who were surveyed. Now let's put this into a decimal like it said. 35 divided by 53. That gives us that decimal. It says round to 2 decimal places. If we were to round to this point here, it would stay as 6. So this becomes 0.66. Okay, and now finally a check for understanding question. In order to get credit for this class, you have to complete this problem on a separate sheet of paper. and upload your answer to the Google Classroom. Have a great day, guys.